Download this code from codegive.com, link in the description below. L40 Register Allocation and Assignment in Compiler Design. Register allocation is a crucial phase in the compilation process, where the compiler decides how to assign variables to a limited number of registers available in the target architecture. Register allocation can significantly impact the performance of the generated code, as accessing registers is faster than accessing memory. Overview of L40 Register Allocation. The term L40 typically refers to a specific algorithm or method for register allocation and assignment, though it is not a widely recognized term in the literature. However, we can discuss the general principles of register allocation, focusing on graph coloring, which is one of the most common techniques used in compilers. Steps in register allocation. 1. Building the interference graph. The first step is to create an interference graph where each node represents a variable, and an edge between two nodes indicates that the variables cannot be assigned to the same register, they are in use at the same time. 2. Graph coloring. The next step is to color the graph using a limited number of colors, where each color represents a register. The goal is to ensure that no two adjacent nodes share the same color. 3. Spilling. If the number of registers is insufficient to color the graph, some variables may need to be spilled to memory. This means that rather than keeping the variable in a register, it is stored in memory, and the compiler generates additional code to load and store the variable as needed. 4. Code generation. After successfully assigning colors, registers, to the variables, the final step is to generate code that uses these assignments. Example of register allocation using graph coloring. Let's consider a simple example where we have a set of variables and a sequence of operations that use these variables. Step 1. Build the interference graph. Assume we have the following variables and their usage in expressions: x, y, z, a, b. Consider the following code snippet. From the above code, we can determine the variable interference. X interferes with y, z, and a. A interferes with x and b. Z interferes with a and b. Using these relationships, we can build the interference graph. Step 2. Graph coloring. Let's assume we have three registers available, R1, R2, R3. We need to color the graph such that no two adjacent nodes share the same color. A possible coloring could be X-R1, Y-R2, Z-R3, A-R2, spill if necessary, since Y and A cannot share the same. B-R1, spill if necessary, since A and B cannot share the same. Step 3. Code generation. After assigning registers, we generate code that uses the register assignments. Conclusion. Register allocation is a complex but essential task in compiler design. The L40 method, or graph coloring technique, is an effective approach to allocate registers efficiently. The example demonstrated the process of building an interference graph, coloring it, and generating corresponding assembly code. In practice, compiler implementations may use more sophisticated techniques, including different heuristics for spilling and optimization strategies to improve the quality of register allocation.